Hey everybody, welcome to our second lesson within our newest unit, chemical quantities. Again, this is all about the math of chemistry. Today we're going to be talking a little bit about percent composition and specifically percent composition by mass. You guys have had a little bit of exposure to this in one of the previous lab activities we did, lab activity number 1, where we looked at separating mixtures and calculating percent composition. But I thought I would teach this lesson in a little bit of a different way today and talk a little bit about gold mining, okay? So kind of fun. So let's just envision this, okay? Envision that you and your friend go on this beautiful hike and you come across two different caves. And the first cave, you find some gold ore, and in the second cave, you also find gold ore. And you guys decide that you guys are going to take equal samples from cave 1 and cave 2, okay? And the question becomes, which cave are you going to take? Now, let me explain this. Let me backtrack. Gold ore is not pure gold, okay? It's going to be a compound that contains gold. And so you want to know which of these two caves is actually going to be able to provide you with more money in the end, okay? If you're following along on the notes sheet, this does start you off, but if you're not following along on my guided notes sheets, there are going to be two options for our caves. Okay, we have cave number 1. And in cave number 1, we find that the compound is gold 3 chloride. And in cave number 2, okay, we find that the sample is gold 2 oxide. Okay, now remember, gold requires the use of Roman numerals because it is a transition metal that contains multiple oxidation states or multiple charges. So we have gold 3 chloride and gold 2 oxide. And so again, our goal is to figure out which of these caves, if we take equal samples, let's say we take, I don't know, 100 grams from each cave. Okay, we want to find out which one of these caves is going to provide us the most money or the best profit in the long run. So the first thing that I want us to do is I want us to go ahead and just get the chemical formula for each of these compounds. So again, this is going to involve the crisscross method. It's a good review for ionic bonding. And so we need to look up our symbol for gold, which is going to be Au, and chloride, which is Cl. And from here, we need to determine the charges. Now, again, I love stock system naming with the Roman numerals because it tells us the charge of the gold right there. Gold 3 literally means that this forms a +3 ion, and the chloride, most common oxidation number from our periodic table, is a -1. From there, we're going to criss and we're going to cross, and we end up with the chemical formula of AuCl3. Okay? If you want to try the second one on your own and pause, feel free to do that. Otherwise, I'm going to go through it right now. Okay, so we have gold, again, Au, and oxide, which is O. Gold 2 means this is literally a +2 charge, and O, the most common charge, and actually the only charge listed on our periodic table, is a -2. And we're going to criss and we're going to cross, and we get Au2O2, which, remember, reduces to become AuO. Okay? So now we have our two chemical formulas of our two caves. We have AuCl3 and we have our AuO. Okay? Our two chemical formulas. But just looking at those chemical formulas isn't enough information to tell us which one of these caves contains more gold, okay? So why is this not the case? Why is this just not enough, okay? Not enough information. So again, it's not pure gold, and so we need to look at how much gold is this going to produce, right? So what percentage of this compound is gold, right? What percentage of my 100-gram sample is actually gold? And again, the same thing for my Au2O, right? What percentage of this is actually gold. Okay, so I take 100 grams, but that 100 grams isn't pure gold. We need to figure out which one of these contains more gold. And so in order to do that, we're going to use, again, what's called percent composition by mass. And so percent composition by mass is exactly what it sounds like. And there's no real definition for it, but there is actually an equation for percent composition. In fact, if you need it, it's on the back of your reference table on table T. Okay, and our percent composition by mass equation, okay, is going to be equal to mass of part over the mass of the whole multiplied by 100. Okay, and so this equation is very important for us. It's going to help us determine of these two compounds which contains the most gold out of the two. And so when we talk about mass part over mass whole, we don't have that information, right? We know we have 100 grams, but that's not the mass of our whole. Our mass of our whole is actually going to become your, or what we're looking for here is the GFM, the gram formula mass, okay? And from there, the mass of the part, since we're interested specifically in looking at which percentage is gold here, we're going to be using the percent or the mass of just the gold. So both of these, the first step that we need to do is we need to calculate the gram formula mass of the two compounds. So let's go ahead and calculate those now. So we have, again, AuCl, okay, Au, we have 1, Cl, we have 3, and we're going to use our reference table to help us figure out our masses. So our mass of our gold is going to be 190, I just lost it, 0.97, okay, grams. And we have chlorine, okay, which is going to be 35.45 multiplied by 3. And we are going to go ahead and calculate that. So we get 196.97. And we get 35.45 times 3, which is going to give us 106.35. And we're going to add those two values together to get our total mass, 196.97. Okay, I'm sorry, 303.32. I was reading out what I was typing in my calculator. Okay, so this is going to be our gram formula mass. Grams per mole is our units. And from here, we can now calculate what percentage of our compound is made of gold. So again, we're going to use that percent composition by mass, but specifically we're interested in what percent composition of Au from our compound. Okay, so we're going to take our mass of the part, which again is the mass of the Au. And so Au in this case was 196.97. And we're going to divide that by our total mass, or the mass of the GFM, right? That's the mass of our full compound. At the end, we're going to multiply that by 100. That does need to be included in order to show all work. I know it's kind of a silly step to include, but if for some reason this showed up on, let's say, a test or a quiz, this is part of the numerical setup. If they do ask for that, that 100 needs to be there. So we do 196.97 divided by 303.32 and multiply that by 100. And so 64.94% of my gold sample, or of my sample that I take from the cave, is gold. So if we wanted to think about that again, we hypothetically took 100 grams of gold from our cave, okay? And so 64.94% of that is gold. So if I were to isolate or to purify my sample to just get the gold, right, I would get only 64.94 grams of gold, okay, out of my 100 gram sample. Okay, so what I'd like you to do is I'd like you to just pause the video at this point. I want you to go ahead and try the second one on your own, and then we're going to come back and we'll go over it together. So go ahead and hit the pause button now. Okay, welcome back. So let's go ahead and go over the remainder or the other problem here. So hopefully at this point you've calculated the gram formula mass and the percent composition and how many grams of gold you would get. So we have here AU, okay, and we have O. AU is 196.97, okay, and there are one of them, so that gives us a total of 196.97. We have oxygen, which again we have is 16.00, and we have one of them, so that gives us a total mass of 16. From there, we're going to add our values together to get our gram formula mass. So 196.97 plus 16 gives us 212.97 grams per mole. From here, we can set up our percent comp of AU, which again is going to be mass of part 196.97 divided by 212.97. Multiply that by 100, and that's going to give us a final percentage of 212.97, 92.45%. And so from this cave, of your 100-gram sample that you take, of that cave, 92.45 grams is actually going to be gold. And so even though you took equal 100-gram samples from cave 1 and cave 2, because their percent composition varies, cave 2 actually gives you a substantially larger sample of pure gold than cave 1. So our final answer here would be, okay, to use cave 2, right? So cave number 2 produces more gold, okay? And that, my friends, is percent composition by mass. And I look forward to working on this with you in class. Have a good rest of your day.